Welcome to this video summary on inventory management for perishable products. In the paper, Jake Clarkson, Michael Volkel, Annalena Sachs and myself develop an inventory model that takes into account the perishing process of products. We show how the model can be solved, optimally for small instances and heuristically for large ones. And we demonstrate the benefits of using our model as opposed to traditional models. Our results indicate that taking the perishing process into account when making inventory decisions, as we do, can lead to substantial cost savings and to reductions of food waste. I now hand over to Annalena for more information on the problem setting.
Thanks, Ulrich. Imagine you're going to a retail store and you want to buy some fresh products like fruit and vegetables. The retailer offers a large assortment with many different kinds of fresh products, and those products are really important to attract you as a customer to their store. Now, consider the retail manager. The retail manager wants to make sure that you as a customer find the products that you wish to buy, but also they don't want to order too much as those fresh products perish and would then result in food waste. To solve this problem, we develop an inventory model that determines how many items the retail manager should order. In this model, we consider that fresh products like fruit and vegetables perish. Each item arrives in the store, and then while sitting on the shelf, the probability that it perishes increases from day to day until eventually it will be thrown away if it has not been sold after a couple of days. What is special about our model compared to other models in the literature is that we consider that items perish independently. This means that one bad box of strawberries or one bad bunch of bananas does not spoil the whole batch. Instead, each product has its own perish probability. Jake will summarize next why this model is important in practice.
Thanks, Anna. Understanding and modelling the perishing process is very important. Firstly, because we want to avoid items perishing, as the retailer clearly makes a loss on perished items, and there could even be further costs of disposal. And secondly, because perishing affects future stock levels. In other words, it affects how many bananas we will have left to sell tomorrow, which then affects how many new bananas we want to order today. Current perishing models may lead to tractable solutions, but they are overly simplistic. On one extreme, the newsvendor model assumes everything perishes at the end of the day, whilst on the other extreme, the periodic review model assumes that nothing ever perishes. Our newsvendor is suitable for newspapers, and PRV for products with long dates such as sugar or salt, but neither is suitable for fresh produce. Our model considers the much more realistic independent perishing described by Anna on the previous slide. We can calculate the optimal policy for small problem sizes, whilst for larger problem sizes, we develop a heuristic called the age-dependent PRV, an adjustment to PRV that captures the independent perishing process. With real and simulated data, ADPRV shows big savings compared to PRV and newsvendor, which are often used in commercial software in retailing. In the simulated case shown in the graph, we see that ADPRV tracks the optimal policy very well, whilst being also a lot quicker to calculate.
Thanks, Jake. I'm very happy that we can provide an approach for solving the class of inventory problems that we analyzed. As you saw, taking the perishing process into account can result in large cost savings and in reductions of food waste. The tools for achieving this are now available to you, and they are available in our open access paper that can be downloaded. I hope that you enjoyed this brief summary and wish you a nice day.